Alright, let's be honest, ammo can be confusing as hell. We've got numbers, letters, decimals, acronyms. It's like trying to read a secret code. 9mm, cool. 223, sounds fast. 300 blackout, sounds like it should come with a cape. Today I'm breaking down ammo basics so you don't look clueless at the gun counter. So whether you're brand new or just tired of pretending you know what plus P means, this is Ammo 101. Let's get into it. First, let's break down what a round of ammunition actually is, because no, the whole thing is not called a bullet. That's just one part of it. Referring to the entire cartridge as a bullet is like calling Bruce Jenner a woman. But it leaves out the critical components that make it function. A standard round of modern ammunition consists of 4 main components: the case, the primer, the powder, and the projectile, aka the bullet. First, let's talk about the case. This is the outer shell that holds everything together. It's most commonly made of brass, but you'll also find steel or aluminum cases out there as well. Brass is preferred for its durability and corrosion resistance, plus it can be reloaded multiple times if you're into reloading. The case isn't just a container. When a round is fired, it expands to create a tight seal in the chamber, and this seal is critical because it helps prevent gas from escaping backwards and ensures that all the pressure goes where it's supposed to, forward, driving the bullet out of the barrel. Next is the primer, which is located at the base of the cartridge. It's a small, sensitive metal cup filled with a shock-sensitive chemical compound. When the firing pin strikes the primer, it creates a small but powerful spark, igniting the powder inside the case. Think of it like the spark plug in your car. It kicks off the combustion process but doesn't provide the power on its own. Unless you're Tanner's 911 and then nothing works. I'm sorry, you're gonna hate me for that. Now you can have a rimfire or a centerfire. For rimfire, the primer is on the rim of the cartridge, and centerfire, like the name suggests, the primer is in the center of the cartridge. Inside the case is the powder, often referred to as gunpowder, though modern ammunition actually uses smokeless powder. Unlike black powder, smokeless powder burns extremely fast and efficiently, so it doesn't explode in the Hollywood sense. Instead, it rapidly converts into gas, building up the pressure in the chamber. That pressure is what launches the bullet forward, turning chemical energy into kinetic energy. The amount, burn rate, and type of powder inside vary depending on the cartridge's purpose, target shooting, hunting, self-defense, etc. Finally, we get into the projectile, the actual bullet. This is a part of the cartridge that exits the barrel, travels downrange, and hits the target. Bullets come in all shapes, sizes, and types: full metal jacket, hollow point, soft point, frangible, you name it, and we'll get into that later. But the bullet shape and composition determine how it behaves on impact, how it travels through the air, and what it's best used for. So if you're watching this video, it means you're a shooter, it means you're buying ammo, so I quickly want to shout out a sponsor of the channel, that is Ammo Squared. If you are out on the range often, you know how important it is to keep a steady supply of ammo on hand and not rely on last-minute restocks or inconsistent availability. That's where Ammo Squared comes in. They are America's ammunition reserve. You pick from over 70 different calibers, set your monthly budget, and just let it build up over time. When you're ready, you ship it. They store everything in climate-controlled facilities so your ammo stays in good shape until you need it. No hidden fees, no minimums, and shipping's free on orders over $250. I found it's a solid way to keep training ammo stocked without having to think about it, and it's also great if you have a small budget or just want to stockpile without spending hundreds or thousands of dollars up front. Now that we've covered what ammo is made of, let's get into the most misunderstood aspects of ammunition: caliber. At its simplest, caliber refers to the diameter of the bullet, the actual projectile that leaves the barrel. This diameter is measured in This diameter is measured either in inches using a decimal like 0.45 or in millimeters like 9mm. For example, 9mm means the bullet is approximately 9mm wide, while 45 ACP is 0.45 inches in diameter. Easy enough, right? Not quite. The confusion starts when people assume that caliber tells you everything you need to know about a round. In reality, caliber only tells you the bullet's width, not the cartridge length, shape, pressure, or what gun it fits in. For instance, 223 Remington and 5.56 NATO both use a bullet that's about 0.224 inches wide, but the 5.56 NATO is generally loaded to a higher pressure and has different chamber specs. While you can safely shoot .223 in a 5.56 chamber, doing the reverse can be dangerous depending on the rifle and the ammo. It gets even trickier when you compare something like .308 Winchester and 7.62 by 51 NATO. These two cartridges are very similar and many people use them interchangeably. But again, .308 is often loaded to a slightly higher pressure and has tighter tolerances. Another example is .357 Magnum and .38 Special. Despite the name difference, both use bullets that are .357 inches in diameter. A .357 Magnum revolver can safely shoot .38 Special, but the reverse is not true. The Magnum has a longer case and significantly higher pressure. Part of the confusion also comes from the bizarre naming conventions we've inherited. I can't say that word. Some cartridges are named for the year they were adopted, like the .30-06 Springfield. .30-06 adopted in 1906. Others include case length like 7.62 by 39, which is used in AK pattern rifles. Then you have cartridges like 300 Blackout, which sounds like a superhero name, but it is designed for suppressed AR-15s. The bottom line is this: 2 rounds can have similar sounding names or the same bullet diameter, but behave very differently and are not always interchangeable. So even though a .223 wants to be a 5.56, it can't. It is a .223, and you can't do anything about it. You just can't, Nemo.
You think you can do these things, but you just can't, Nemo.
To avoid mistakes, always match the ammo to the markings on your firearm's barrel or frame. If it says .223 Remington, don't assume you can shoot 5.56 NATO unless your rifle is specifically rated for it. And don't rely on visual similarity. Some cartridges look nearly identical but have different pressures or chamber specs that could cause malfunctions or damage. In short, caliber is just the start of understanding ammo. It tells you one piece of the puzzle, but you also need to know the cartridge name, dimensions, pressure rating, and the compatibility with your firearm. Now that we've covered caliber, let's get into the different types of bullets you'll come across, because not all bullets are the same. The type of bullet you use can make a huge difference in how it performs in a variety of situations, whether you're at the range, defending yourself, or hunting. Understanding bullet design is crucial to getting the most out of your ammunition. So let's break down the most common types of bullets you'll see. Full metal jacket is probably the most well-known and widely used bullet type. It's often what people think of when they imagine standard ammunition. The FMJ consists of a soft lead core that's entirely encased in a hard metal jacket, typically copper. The jacket serves a couple purposes. It helps the bullet maintain structural integrity as it travels down the barrel, and it prevents the barrel from becoming fouled with lead deposit, which can happen with plain lead projectiles. FMJs are often used for target practice and range shooting because they are affordable, reliable, and durable. However, they have one significant drawback, and that is over-penetration. FMJ bullets do not expand upon impact. This means that they tend to pass right through their target, potentially hitting unintended objects or even people behind the target. While this is not usually a problem at the range, it can be dangerous in self-defense situations. For example, if you're shooting in an urban environment during a self-defense or home defense situation, the last thing you want is a bullet traveling through a threat and continuing into a wall or into a bystander. For self-defense or law enforcement, the jacketed hollow point is a top choice. Unlike the full metal jackets, the jacketed hollow point bullets are designed to expand upon impact. The hollow point is located at the tip of the bullet, and when it strikes the target, it compresses and opens up, increasing the size of the wound channel. Man, that tip does a lot of damage. The hollow Okay, sorry, okay. I feel like I do a better job when Tanner's not breathing down my neck watching me. All right. This causes the bullet to transfer more energy into the target, stopping the threat more effectively. The expansion also reduces the risk of overpenetration, which is why JHPs, or jacketed hollow points, are often preferred for personal defense and law enforcement applications. One of the main advantages of hollow point ammunition is its ability to deliver stopping power while minimizing the risk of collateral damage. For example, if you're using hollow points for self-defense in a home, the bullet is less likely to exit the target and strike something or someone else. This makes hollow point ideal for high-stress scenarios where you need to stop an attacker without worrying as much about the bullet causing harm beyond the target. The soft point bullet is a hybrid between full metal jackets and the jacketed hollow point. It is a partially exposed lead tip that allows it to expand upon impact, but not as aggressively as a hollow point. The expansion is more controlled, allowing the bullet to penetrate deeper while transferring energy to the target. Soft points are often used for hunting, especially when you need a bullet that will penetrate the target without causing excessive damage to surrounding tissue. Soft point bullets are effective for taking down like medium to large game. They provide the necessary penetration to reach vital organs while ensuring a more controlled wound channel than a full metal jacket. For hunters who need to ensure a clean kill without risking over penetration or excessive fragmentation, soft point bullets are a solid choice. If you're looking for safety during training, frangible ammo is a great option. These bullets are designed to break apart upon impact with hard surfaces like steel targets or concrete. Frangible bullets are typically made from compressed metal powder or other brittle materials. When they hit a hard surface, they shatter into smaller pieces, reducing the risk of ricochet or dangerous backsplash. Frangible ammo is particularly useful for close-range training, indoor ranges, and military training, where safety is a primary concern. It's ideal for environments where traditional ammo might pose a danger due to ricochet or when you need to minimize the potential for collateral damage. However, frangible ammo isn't designed for deep penetration, so it's not suitable for self-defense or hunting larger animals. The ballistic tip bullet combines the aerodynamics of a full metal jacket with the expanding power of a hollow point. It is a plastic tip at the front, which drives back into the bullet upon impact, initiating rapid expansion. This type of bullet is popular for long-range shooting and hunting because it offers both accuracy and stopping power. The plastic tip provides the bullet with better aerodynamics, helping it fly more consistently and accurately over longer distances. Once the bullet hits the target, the tip pushes back into the bullet, causing it to expand quickly and transfer its energy efficiently. Ballistic tip bullets are great for hunters who need a highly accurate bullet that won't compromise on terminal performance. They are also effective for varmint hunting, where precision and the ability to stop a small animal quickly are essential. These bullets offer the best of both worlds, combining long-range accuracy with controlled expansion. Now, there are some specialty rounds that are designed for specific situations or high-performance needs, such as +P ammunition. This is ammunition loaded to a higher pressure than standard rounds. The higher pressure generates more velocity and energy, making +P rounds ideal for self-defense when maximum stopping power is required. However, not all firearms are rated to handle +P ammo, so it's essential to check your firearm specifications before using these rounds. We also have subsonic ammo. Subsonic rounds are designed to travel below the speed of sound, about 1,100 feet per second. These rounds are used with suppressors to keep the noise level down. Since they don't break the sound barrier, they don't produce that sharp crack that supersonic rounds do, making them ideal for sound suppression. I actually recently used subsonic ammo in this Hue Honey Badger, suppressed, and holy crap was it amazing. All you hear is basically just the bolt racking, and that's it. Something you should definitely experience at least once in your life. But moving on to tracer ammo. So these rounds have a small amount of incendiary? These rounds have a small amount of incendiary material in the base of the bullet that lights up as it travels through air, leaving a visible trail. Tracers are useful for target identification, adjusting fire, and shooting in low light conditions. They are often used in military and tactical settings, but they're not typically practical for civilian use in most situations. We also have armor-piercing ammo. These bullets are designed to penetrate hard armor like bulletproof vests or vehicles. They're often made with harder materials like tungsten or steel and can penetrate steel or ceramic armor plates. However, armor-piercing ammo is highly restricted and illegal in many jurisdictions for civilian use. So when you pick up a box of ammo, you'll likely see a grain weight printed on the packaging, but what exactly does that number mean and how does it affect the bullet's performance? The grain is a unit of weight used for measuring bullets and other small items. And while it may seem like a small number, it plays a significant role in determining how a round behaves once it leaves the barrel. So grain is a unit of mass commonly used in firearms and ammunition, where 1 grain is equal to 1/7,000th of a pound, or roughly 0.0648 grams. When you hear that a bullet is 115 grain, that means the projectile weighs 115 grains, or about 7.46 grams. In most ammo, the grain weight refers to the weight of the projectile, the bullet itself, not the entire round. This weight has a direct effect on the speed, penetration, and overall performance of the bullet. For instance, in rifle calibers like the .308 Winchester, typical bullet weights range from 150 to 180 grains. A 180 grain bullet carries more energy than a 150 grain because of the greater mass. While heavier bullets typically have lower velocities because they require more energy to push out of the barrel, Their greater mass helps them maintain momentum and penetrate better than lighter bullets. Heavier bullets are also more stable in flight, particularly at longer ranges. They are less susceptible to wind drift and tend to maintain a straighter trajectory over long distances. Stay straight. This is why snipers and long-range shooters often choose heavier bullets for precision shooting. The increased weight also allows the bullet to retain its energy over distance, meaning it is less likely to lose velocity quickly. However, there is a trade-off. Heavier bullets experience more barrel friction and they generate more recoil. On the other side of the spectrum, lighter bullets have a higher velocity, meaning they leave the barrel faster. However, the downside is that lighter bullets often have less stopping power compared to heavier bullets, and they can be more affected by wind drift or environmental conditions. The lighter mass also means they tend to lose velocity quicker and lack the penetration needed for larger or armored targets. When deciding on a bullet weight, you need to consider both your firearm and your intended purpose. While bullet weight is a crucial factor in performance, bullet design plays an equally important role in bullet's trajectory, accuracy, and effectiveness once it hits the target. The shape of the bullet is critical for its aerodynamic performance, and bullets are designed to minimize air resistance, and the more aerodynamic a bullet is, the more stable in flight it'll be. So let's go over some of the common bullet shapes and their effects on performance. Spitzer bullets, or pointed bullets, have a sharp pointed tip that are used in long-range shooting and rifle ammunition. The streamlined shape reduces drag, allowing the bullet to maintain speed and accuracy over longer distances. Spitzer bullets are highly aerodynamic and ideal for precision shooting. They're commonly used in calibers like .308, .223, and .65 Creedmoor. With flat-nosed bullets, these bullets have a blunt nose and are often used in handgun calibers. While they don't offer the same level of aerodynamic efficiency as Spitzer bullets, flat-nosed bullets transfer energy quickly to the target, making them excellent for shorter range engagements. They're often used in target shooting, hunting smaller game, or personal defense. There's also boat tail bullets. Boat tail bullets have a tapered rear, and they're designed to improve stability in flight, reducing drag and increasing the bullet's velocity retention over long distances. Boat tails are favored by precision shooters and snipers for their ability to maintain accuracy at extreme ranges. And we also have the hollow point bullet. It is designed to expand upon impact with a target, like we kind of already mentioned. While hollow points are primarily used for self-defense and hunting, their design can affect their trajectory in flight due to the cavity in the tip, which can reduce aerodynamic efficiency. So let's go over something called ballistics coefficient. A bullet's ballistic coefficient, BC, is a measure of how well it resists air drag as it travels through the atmosphere. The higher the BC, the less wind drift and velocity loss the bullet will experience at longer ranges. A bullet with a high BC is usually pointed and streamlined, which allows it to retain speed and maintain a flatter trajectory. This is particularly important for long-range shooting, where small changes in trajectory can result in large shifts in impact point. A high BC bullet will fly more predictably, especially in windy conditions. This is why long-range competitors and snipers prioritize high BC ammunition, as it gives them a competitive advantage in maintaining accuracy at extreme distances. Alright, to sum it up, ammo might seem simple, but there's a lot to consider, whether it's the type of round, the right caliber, or the grain to choose, but always choose ammo that suits your needs, whether for practice, defense, or hunting, and make sure it's stored safely and securely. Well, thanks for watching, and I hope this gives you more confidence in understanding and choosing ammo. But go ahead and like, subscribe, check out the ways to support the channel down below, and we'll catch you in the next episode.